Hello students, in this lecture some other application of parabola in physics will be discussed, but let us start from the point where we have left in the previous lecture. In the previous lecture, Subbu sir has explained the equation of the projectile motion can be rearranged in this form, and we have left at this point. Now the last step to calculate the vertex or the coordinate of the vertex is this step. So this you have to do. Now if you have gone through the steps and you have solved this question, you just match your equation with this equation. If you are getting this equation, your answer is definitely correct. Now, what is the importance of doing all these things? So the importance of all these things that we have discussed in the last lecture is just by comparing this equation, we can see that we will get two important parameters during the motion of a projectile. And what are those two important things? One is the maximum height attained by the parabola, and second is the range that the parabola can achieve in a given value of u and theta. So what is maximum height and what is maximum range? So I am just going to give you a brief explanation. This point, that is the highest point during its motion, the height of this point is called maximum height and denoted by capital H. And this distance, that is the point at which it will land back on the horizon from the point of projection, is called the range of the parabola. Now you can see that this is the vertex also. So the coordinate of vertex will be h and r by 2. So if I calculate the coordinate of the vertex, this is the y coordinate of the vertex and this is the x coordinate of the vertex, what I will get is capital H and r by 2. And these are two very important parameters of parabolic projectile motion. So from here I can write this r by 2 or here h as u square. This I can write as sine square theta upon cos square theta. Cos square theta into sec square theta is 1. So it is simply u square sine square theta upon 2g, and this is the formula of maximum height also. Now from here I can write this expression as r by 2 is equal to u square into sine theta upon cos theta. Now 1 cos theta into sec theta will be 1 and 1 sec theta will go upward and it becomes cos theta. So u square sine theta upon cos theta upon g. So if I take this 2 here, so value of r will be this. From trigonometry you also know that 2 into sine theta into cos theta can be written as sine 2 theta. So I can write r as u square sine 2 theta upon g. So the two important parameters of projectile motion can be simply calculated by just comparing the equation of our projectile motion with the standard form of equation of a parabola. So this is how mathematics help you both understand and appreciate the concept of physics at various places. Now coming to another important application of parabolic path, I am going to discuss one important case of fluid mechanics. Now what is that concept? Let us say I have a liquid kept in a bucket and I am rotating this bucket with some angular velocity, let us say omega here. Now you can simply do this basic experiment and you will know that the shape of the surface of this liquid will be in this form, that is of the form of some parabola whose vertex can be given by this point here. So this is the shape of the liquid. Now can I get the equation for this shape also? So let us try to get this. Now let us consider a point on the path of this projectile or the parabolic equation here. So let us say I am considering a point P on this path. Now I can say that this point is moving along a circular path. What is the radius of this circle? So if the coordinate is x, y, let us say our origin is here. So the x is the radius of its circular motion also. Now hold the surface will apply some reaction force due to contact on this point. Let us say the reaction force I am giving as capital R here. So now if I draw a tangent at this point, you can see that this angle is theta here. So can I get the value of this angle from here? You can see that this angle is theta, then this angle is also theta. Since this is tangent and this is normal line, so this is 90 minus theta, so this angle is again theta. So the component of normal reaction along vertical and horizontal can be written in a similar fashion that we have discussed in the case of projectile motion when I break the velocity into x and y component. Here also I can write component of r along y axis r cos theta, and along this line I can write as r sin theta. So you know that for a particle to move along a circular motion, there must be a force, that is centripetal force, acting on that particle that acts along the center of the path. So here I can say that r sin theta is providing that force here. So I can write r sin theta as the centripetal force, which is equal to m omega square r. dm is the small mass of a particle. This particle is a very less mass. Omega is the angular velocity and x here is the radius of its path also. Along y direction I can say that the particle is not moving. So this force must get balanced by the gravitational force that is acting downward, dm into g here. Now I can simply divide these two equations and we will get tan theta as omega square x upon g. Now from calculus we know that the slope or the value of tan theta that the tangent is making with x axis can be written as dy by dx. This is the basic definition of slope and that we have already discussed in calculus. And that
go to this link and just see that library and you will find all the things you need for calculus in physics there.
That is already there in our YouTube channel. So just go through that library. So dy by dx, that is slope of a curve, can also be written as tan theta. Now here I already know the value of tan theta. So what I can do is I can write this tan theta as omega square x upon g. So dy can be written as omega square x upon g into dx. Now to get the equation I need to integrate this, and here I am doing indefinite integration. The details of indefinite integration is also there in the library. So just go through the library and you will find the way in which the indefinite integration can be solved. So here the integration will be y is equal to omega square x square upon 2g plus c. Integral of x dx is x square by 2 and c is called constant of integration. This I can find by some given condition here. Now how I can find the value of c? So when x is equal to 0, you can see that the value of y, this value is the minimum value along the path of this parabola. So this value is known to us, which is y minimum. So at x is equal to 0, I can write y is y minimum. So when I put the value of x and y here, what I will get is y minimum is equal to c. And hence I can write the equation of this parabolic path as y minimum plus omega square x square upon 2g. So what we have discussed here is considered to be a difficult concept of fluid mechanics, and generally for student of class 11 these concepts are generally not taught in the class. But if you understand the concept of parabola, this will not look very difficult to you. So this is how the relation between physics and mathematics lies. Once you understand mathematics, even difficult concept of physics will look simpler to you. Otherwise, Generally, these concepts are avoided just because the mathematical portion makes it slightly difficult to understand for the students. So now, just go through the concept that we have learned here, and you will appreciate both the properties of parabola and its application in physics. So this library will be completed, and in some other discussion we will come across with the other part of the conic section, that is hyperbola and application of hyperbola in physics. So for this lecture, thank you for attending this class, student. Next lecture we will discuss interesting concept of mathematics and physics. Thank you, students.
Thank you.